Okay, hi guys. First, I'm gonna post the schedule in the live chat. Okay, and then so Unit 3 review. So first, Chapter 11 is on simulations. So simulations model real-life situations, and they're often a cheaper way to see what happens. So component is examples are opening a box, rolling dice, selecting a student, and when writing a simulation, you first want to state the component, and I'm using the tennis racket example, so the component here would be matches, and then how you will model. So you want to assign the digits. So you want to say if you're using single digits or double digits. So in this case, 0 to 14 is if it breaks, and 15 to 99 is if the racket doesn't break. And then you want to say the independence assumption. So to do simulation, the outcomes must be independent. And then describe a trial. What steps will you take? So you'll take a 2-digit number from the random number table. You can also use a random number generator. And what will you record? You record the number of matches in this case, and then when will you stop? Until the racket breaks. And are repeats okay? And yes, they are okay, or else it won't be a 15% chance. And most importantly, you need to state the response variable. And in this example, it's how many matches played before the racket breaks. And you can see in the data table, you'll have the trial, and then the component, and then the response variable. And in the component, it's the random numbers. And in this example, so the average number of matches I got was 4.4. And then, so your conclusion, you must say, according to my simulation, I expect the racket to last an average of 4 to 5 matches before breaking based on my 4.4 average. Okay, so now moving from simulations to sample surveys, Chapter 12. So in sample surveys, the fraction of a population that you sample doesn't matter. It's the sample size that matters. So it doesn't matter if, say, you ask like 90% of the population. Well, actually, there's a 10% condition, which we'll talk about later, but we want a big sample size. And so bias versus variation. Bias is an error of accuracy, while variation is error in consistency. And bias is a systematic error, while variation is inherent error, which means there's always going to be variation. Oh, I got a question. How do you reduce bias and variability? Oh, we're just getting to that. Okay, so to reduce bias, you want to make it random, and variation, you reduce it by making it a larger sample. Okay, and back to inherent error, we want, it'll always be there. There will always be variation between the samples. So it'll always be there, but we can reduce it by getting a larger sample size. And now sampling error versus non-sampling error. So, I forgot about census. So census is when the sample consists of the entire population. So you ask everyone, which can often be hard because depending on how big the population is, which is why census, you cannot always use that. Okay, sampling error is error in choosing the sample. Example is undercoverage. It gives part of a population less representation than they should. So for example, if you want to know SAT scores of students, but your sample only has, say, 2 girls instead of 10, and then 10 boys, then the girls would have less representation than they should. It should be 50-50. And voluntary, so you don't want to do a voluntary you don't want that because usually people who respond are more passionate, so they might be more against it or more in favor of it. So, and also convenience, you don't want to do that because convenience is when you choose individuals who are easiest to reach. So that won't be representative. That would be like whoever the first 10 people who walk in to the school, but that wouldn't be representative because, for example, you might miss like the people who come late to school, and so that's not representative of the whole population. And then non-sampling error is error in choosing the question. So example is non-response bias. So that's when respondents don't or can't respond. So like calling during the workday, then people who are at work or might not be able to respond. So that's non-response. And then response bias is when there's external influence, like wording, or the topic. For example, of response bias could be maybe like, don't you agree with this? Then they'll feel more obligated to say, I agree with you. Okay, and now on to simple random sampling, or SRS, is when each element in the population has equal chance of selection. And then there's cluster, which is a simple random sampling or a census among heterogeneous groups that resemble population. So remember, this is heterogeneous, and while stratified is homogeneous groups, and you're taking a few from each strata. And so the benefit of cluster is usually easier because you're just taking a whole group that is heterogeneous. And stratified benefit is it reduces variability. Okay, and systematic in examples like choosing every 10 people in a line or in some sort of list. And a sampling frame is a list of individuals from which to draw the sample. So for example, well, you can see here, so that's population, it's very big. And then from the population, you have a sampling frame. You don't always have a sampling frame. And then from the sampling frame, you have the sample. And then sampling variability is the difference between samples. And again, there's always going to be differences between samples, but to reduce it, just increase n. Why do you randomize? To prevent confounding variables, to reduce bias. Why do you control? So you can compare to see if treatments are effective, and to compare differences between treatments and placebo. Okay, now on to chapter 13, observational studies and experiments. So the difference, so both of them, you use parameters because we want to talk about the population. So no p-hat or anything like that. And then in observational studies, you randomly select your sample, while experiments, you randomly assign the samples to the treatment. So random select versus random assignment. And in observational studies, you have a 10% condition, while experiments, you're not. And observational studies cannot prove causation. So you can say there's an association between the two variables, but you cannot prove causation. While experiments, if it's well designed, you can prove that they affect each other, so you can prove causation. And observational studies, there's retrospective, which is past, or prospective, which is the current or future. And some vocab words for experiments, there's a factor and level and treatment. So example is, say you want an experiment to see if the lighting matters in tests in your grades. So the factor would be lighting, the level would be a lot of light or no light or middle amount of light. And there's also explanatory and the response variable. And in observational studies, there's no manipulation of factors, while in experiments, you do manipulate the factors. Okay, and now on to the 4 principles of experimental design. So that's control, random, replicate, and block. So control, random, replicate, they're all necessary. Well, blocking is optional. So control, you make the conditions similar. So if you're doing to see if this fertilizer works, you want the plants to get the same amount of sunlight, about same amount of water, same soil, same pot, etc. And a random assignment to treatments. This is to reduce possible like confounding variables. And replicate, so you don't just do the experiment once, you do it multiple times in case something happened during the experiment. And blocking reduces variability, and we'll talk about it more. And you want to compare across the treatments. Okay, and then in diagrams, you want to write randomly assigned over the arrows. So an example, so this is for experiments. If you're doing a tree diagram, you see how they have the arrows over random assignment. So in the diagram, for example, in this example, they have 12 tomatoes and they block it into two groups. Block A has 12 tomato plants and block B has 6 tomato plants. And then random assignment they had 6 groups here. And each group got a treatment and then they compared. And now on to statistically significant means when you believe the differences didn't occur by simple chance. And then if there are differences and it's not just by variation, then you say it's statistically significant. And then single blind. So blinding, you always want to blind if you can because they might have beliefs beforehand. So single blind would be only the subjects don't know, which treatment they're getting. While double blind is when both subjects and analyzers don't know. And a reason why you'd blind, for example, is if you're seeing if which one's healthier, for example, maybe they already believe that this brand is healthier than the other, or something like that. So placebo is a fake treatment. So most of you guys probably know placebo effect. So fake treatment that looks, tastes, feels exactly like the actual. This is to see, to compare to see if there really was a difference. And then there's confounding and lurking variables. So confounding is when levels of one factor are associated with levels of another factor. Lurking, we talked about the last video. It's when there's like this third variable affecting both of them, making it seem like causation when really it's not. And now blocking versus matches. So in blocking, each block is its own experiment. And when groups are similar, you group them into blocks. You can group them into blocks. For example, you can group by age. Maybe group 1 has ages 9 to 10, and etc. And then matching is when each person experiences the same treatment or very similar people get the treatment. So for example, if it's the same person, maybe you're checking deodorant, which one's better, then maybe one armpit you'd have one brand, the other armpit you'd have the other brand. Or you can use twins, for example, they're very similar. Or people who are just very similar, you can do matching. And the benefit of matching and blocking is to reduce variation. Okay, thank you so much for coming, everyone. I'll post the next video soon. Thank you.